Why build your own chatbots? Let us take several cases. The custom data requirements case. Sarah runs a tech support service for a SaaS product. She finds that Voiceflow's integrations with databases and APIs don't fully align with her internal data structure, which involves complex, nested data points with dynamic real-time updates from several proprietary data sources. The data privacy and compliance case. David works in a healthcare organization where he needs a chatbot to help patients schedule appointments and answer queries. He handles sensitive data governed by strict privacy regulations like HIPAA, which require end-to-end encryption and strict data controls. The unique user interface requirement case. Lena is an e-commerce designer working on an interactive shopping assistant for a fashion retailer. Her vision involves a chatbot that not only recommends outfits, but also shows images, interactive carousels, and color options based on user preferences. All within a custom app interface. In these cases, they prefer to build their own chatbots to meet their needs. If you have custom data requirements, proprietary NLP model needs, data privacy and compliance requirements, or want to build a unique user interface, this video is for you. In this step-by-step tutorial, you will learn how to create powerful AI chatbots using the Voiceflow Dialog API, and we'll guide you through the process of building a chatbot platform that allows you to switch between multiple chatbots with a simple click. Key features include: 1. Gemini API Integration. Leverage the power of Gemini API to build advanced AI-powered chatbots. In this video, we use Gemini as an example. In your case, you can use any chatbot you have built. 2. Voiceflow Dialog API. Seamlessly connect to Voiceflow chatbots containing extensive knowledge bases. In this case, we use Voiceflow as backend. 3. Customizable Chatbot Platform. Create a flexible platform to manage and deploy multiple chatbots. The user can switch between multiple chatbots with a simple click. 4. User-friendly interface. Design intuitive user interfaces for easy chatbot interaction. Whether you're a beginner or an experienced developer, this video will equip you with the knowledge and skills to build your own AI chatbot solutions. Let us get started. First, let us go to this GitHub webpage. In our chatbot, we are going to use the front end and style listed in the website. It has a beautiful user interface, and I will use it in this video to save a lot of time in styling. We click on the templates folder. In this folder, there is an HTML file. It contains the chat interface, such as the dialog window, user message form, submit button, etc. We can use it in this video, so we do not need to write all the HTML code from scratch. We click to download the HTML file. In this tutorial, I will use the local host to load the chatbot. In the www folder, I have created a folder called Chatbot. We will put the HTML file, the style file, and the JavaScript files in this folder. The HTML file has a default name, chat. Let us keep this name and save the file in the folder. Next, we click on the static folder. There is a CSS file for styling. It has all the necessary CSS code for our chatbot. We can use it in this video. So we do not need to write CSS code from scratch. We save the style file in the same folder. As we have these files, we can check them in the Visual Code. I have loaded the chatbot folder in the Visual Code. It contains the chat HTML file and the style CSS file, which we have downloaded previously. The CSS file is perfect for the chatbot styling. I like the beautiful styling. We will not need to make any changes for this tutorial. The HTML file has the sections and divs for the chatbot. But it also contains scripts with the JavaScript code. We do not need the scripts, and we will delete them. We will modify it later. For now, we should be able to see the chatbot on the browser as it has the HTML and CSS style. Let us go to the browser and enter the address localhost/chatbot/chat. We see the chat window. But it does not display correctly. The icon image is too big, and the style is messed up. We are going to inspect the problems with the developer tool. We can see there are errors shown on the console. If we click on the link brings us to the file which is empty. This means that the file is not loaded. The status is 404, not found. We need to check the code to see if we have the URL correctly typed. Let us go back to the code. In my previous test, the Bootstrap script had problems when loading. So, here, let us comment out this line of code to avoid the error again. As we have made a change, we want to check again to see if we cause new errors. We refresh the web page, and we still see the 404 not found error. We do not see other errors. This is good. Let us go to fix the error. In the code line 29, the address of the style sheet is not correct. Let us simply replace it with style.css, pointing to the style sheet file, as we can see in this folder. After the correction, we go back to the browser and refresh the web page. We can see the chat window loaded correctly. The style is beautiful. We do not see any errors shown on the console. On the top, there is a very nice chatbot icon. At the bottom, there is a box for the user to enter their questions. We will use this as the front end of user interface to build our chatbots. Back to the HTML file, it has scripts. As we have mentioned previously, we will modify the code. As shown in the script, we have the message area, where the user can enter their question, and click the button to submit the question. There are functions to get the date, hour, and minute, and we have the string time with the hour and minute, which will be shown on the chat window to indicate the time when the chat happens. The user HTML contains the user question and time with an image and classes for styling. This will display on the chat window. We will not use Ajax. The bot HTML contains the answer and time with an image and classes for styling. We will use these in our chatbots. In this folder, we add a new file called chatbots.js. We will add JavaScript code in this file to build the chatbots. In the HTML file, we will move some code in the script to our chatbots.js file. In the code, we have already mentioned the message area where the user can enter and submit his question. We also have the scroll to bottom function. The message format can be scrolled to bottom with the new messages. As we will have our own JavaScript code, we are going to select the entire code in the script and delete it. We save the change to the HTML. Because we have made a change, we want to check the web page again to see if there is any error. We refresh the web page and do not see any errors on the console. This is good. In the visual code, we are going to write JavaScript code in the chatbots.js file. The first code is about the message area where the user can enter and submit their question. In order to give you a better understanding, let us go to the web page and select this area. We can see it is a form. Its ID is message area. This is very helpful when we write our code, and we will use this information. In the chatbots.js file, we write the first line of code. We define a const variable called form. We use the documents method getElementById, and enter the ID of the form, which is message area. The user can input his question, and submit it after clicking the button. We will use a callback function to handle the event. We use the forms method to add event listener with the event trigger of submit. The callback function accepts the argument of event. We use the event.prevent default function to avoid the malicious behaviors after the submit button is clicked. As we mentioned previously, we define a const variable date to save the object of date, which is created using the new keyword. The date object has getHours and getMinutes methods, and we save them to the corresponding variables. We use the variable string time to save the time. We concatenate the hour and minutes with a colon in between. The time will be shown on the chat window to indicate the time when the chat happens. We, then, define a const variable called userQuestion, and save the element to it by using the document getElementById to select the user input element with the ID of text. We also define a const variable called messageFormat, and save the element to it by using the document getElementById to select the element with the ID of messageFormat. We will append the user HTML to this messageFormat to display the user question in the chat window. We will also display the answer from the bot and the messageFormat in the chat window. So, this messageFormat can dynamically add the conversations in the chat window. We will see this at a later time. As we have the text element selected, we can get the user input, and we define a const variable called user HTML. We create an element and save it to the user HTML. We are going to add some elements in user HTML. We use inner HTML attribute to do so. We can copy the code from the downloaded HTML file. Let us paste it here. It has several class names, which is mainly for styling. We have the user question element, which we have defined previously and contains the text element. We use the value attribute to extract the user input question and display it in the message container. We display the string time when the message has been sent. There is a user image displayed along with the question. We will see this more clearly when we test the code on the web page. At this point, it may be a good idea to log out the user question on the console in case there is an error, and we can see it there. This is very helpful for debugging. The user HTML element contains the user question, the message time, and the user image, and we are going to use the append child method to append it to the message form 8, so we can display it in the chat window dynamically. In the next, we will build a chatbot connecting to Gemini API. We will send the user question to the Gemini AI model and get the answer from it. The chatbot will display the answer to the user on the chat window. As we will pass the user question to the Gemini model, we define a variable called question to save the user question. We can extract the user question using the value attribute, which will be passed to Gemini. In order to implement this, we define a function called AIBot. This function accepts two arguments. One is the question. The other is string time, which will be used to display together with the Gemini answer. As we will call this function in this block, we'd better to place this function outside of this block, and we will call this function in this block. Let us make a copy of the function name and arguments, and paste it under the question. So, we pass the question and string time as arguments when we call this function. Now, let's finish this function. As we will make API call to Gemini, we need the Gemini API key. We define a const variable to save the Gemini API key. You can watch our previous video showing how to get the Gemini API key. I am going to paste the API key here. Next, we define a const variable called body data. This body data will be passed to the fetch function when we make the API call. The body data contains an object. We use the JSON stringify method to convert it to a JSON string. In the object, there is a content array. In the array, the parts array has an object which has a key value pair. The key is text, and the value is the user question. When Gemini receives this question, it will return its answer to the user question, passed by the body data. Now, we are ready to write code to make Gemini API call. We are going to use a try-catch block to implement the API call. If there is any error, we can throw the error in the try block, and use the catch block to catch the error. We pass the error argument to the catch block, and we use the console's error method to handle the error if there is one. So we can see the error message shown on the console when the error exists. In the try block, we use a fetch function to make the API call. The fetch function needs an argument with a URL where the API calls go. I am going to paste the URL here. Again, you may watch our previous videos to learn how to get this URL. In this URL we can see the model name. We have the Gemini 1.5 Flash, which is the model we are going to use in this video. At the end of the URL we need to place the API key for the authorization. In addition, the second argument is the HTTP request options object. In this object we define the method as post. In the headers, we enter the content type as application/JSON. In the body, we pass the body data as defined previously. The fetch function returns a promise. When the promise finishes, we use its then method to carry out the next code. After the promise is resolved, it returns an object called response. We check if the response status is OK. If not OK, we will throw a new error object. We pass the string as the error message. We indicate this is due to the Gemini HTTP error, and add the response's status text to show the error details. If the response status is OK, we use the responses JSON method to extract the JSON data and return the JSON data for later use. Next, we use the then method again. We have the argument as the response body, which is returned in the previous promise. We need to validate to see if the structure of the response body is as expected. The response body could be null, or the type of the response body could not be an object. If either occurs, we throw a new error object and pass the error message in the argument. In the string message, we indicate that it is an invalid response body or missing response body. From the Gemini API. This will stop the program. Otherwise, if we have a valid response body object, we can extract the data from it. We define a variable called Gemini answer to save the data returned by Gemini. In the data, we use this response body's first element of its candidates array, and extract the text from the first element in the parts array of the content. Again, you may watch our previous video to learn more details. Now, we have the answer, and we need to display the answer to the user in the chat window. We define a const variable bot.html to save the new element created by using the document.createElement method. We are going to add some elements in bot.html. We use the inner HTML attribute to do so. Again, we can copy the code from the downloaded HTML file. Let us paste it here. It has several class names, which is mainly for styling. There is a chatbot image displayed along with the answer. We have the Gemini answer, which we have defined previously. It will be shown in the message container. We display the string time as the message time when the answer has been sent. We will see this more clearly when we test the code on the web page. The bot.html element contains the Gemini answer, the message time, and the chatbot image, and we are going to use the append child method to append it to the message form 8, so we can display it in the chat window dynamically, just as what we have done with the user HTML element. Until now, we have finished coding the function. We have implemented the HTTP request to send the user question to Gemini, and extract the answer returned by Gemini response. We display the answer to the user dynamically in the chat window. Finally, after the function call, do not forget to clear the user question box. We set its value to an empty string. This will get ready for the user to input his next question. So far, we have finished the code in the chatbots.js file. We have the code which should be able to allow the user to input his question, and display Gemini answer to the user in the chat window. Next, we need to include this code in the HTML file. Back to the chat.html file, we put a script tag, and add its type as module. We define the src as chatbots.js, which points to the JavaScript file in the folder. After saving all the files, we are now ready to test it out in the browser. Let us refresh the web page. On the console, we do not see any errors. This is very good. Now, let's enter a question to ask the bot. We ask, who is the US president? The bot replies, the current US president is Joe Biden. This is wonderful. We enter the next question, what is the area of the US? The bot replies with a very detailed answer. Great! The chatbot works perfectly. If you have followed along, congratulations! Good job! In the following, we will show you how to use Voiceflow as the backend, and communicate with the Voiceflow chatbot via the Dialog API. In some cases, you may want to have your own user interface, but use the knowledge base in Voiceflow. We can still keep our beautiful chat window as the frontend, and use the Dialog API to connect to Voiceflow as the backend. Let me show you how. Let us go to the Voiceflow canvas. If it is your first time to log on, you may see the template, and you can delete it. We will build a very simple chatbot which has a knowledge base that we want to communicate to. Let's go to the main menu, and click the Knowledge button. We click the Add Data Source button, and select the Upload file. We are going to upload the employee data to the knowledge base. This data was generated by ChatGPT and used in our previous videos. It contains the employee's information in the sales department. It has the names, role, salary, and working years of each employee. In our chatbot, we want to get the information of the salespersons. For example, we may ask the chatbot, "What is the John's role?" The chatbot should reply with the correct answer. We may ask any questions related to the employee data, and expect to receive the answers from the chatbot. We are going to build a very simple chatbot, and use the Voiceflow Dialog API to communicate with the knowledge base. On the Voiceflow canvas, we drop a capture block. In the drop-down, we choose the entire user reply. We capture the entire user reply and save it in a variable. By default, the variable is last utterance. Basically, the user question is saved in this variable. We can just use this default variable and use it later. Next, we drop a set AI block on the canvas. We select the knowledge base because we are going to query the employee data in the knowledge base. We pass the user question in the variable last utterance. The bot will find the answer using the data in the knowledge base. We then save the reply in the answer variable. If you cannot find it in your variable list, you can create one. After we save the answer generated by the AI bot, we are going to display the answer to the user. We will use a message block to do so. Let us drop a message block on the canvas. In the message box, we can simply add the answer variable, which saves the bot's answer to the user question. This message box will then show the answer to the user. Let us connect the start and all the blocks. The logic flow is that the bot captures the user question, searches the data in the knowledge base, generates the answer, and displays the answer to the user. In order to let the user ask next questions, we need to connect the last message block to the capture block. So, after the user asks his question and receives the answer, he is able to ask the next question, and the bot will display the answer, and so on so forth. The user can continue the conversation. As we have finished building the chatbot, we can click the button to publish the chatbot. The project version will be production after we publish the chatbot. If you do not publish it, you still can run the chatbot, and the project version will be development. When we fill out the Dialog API parameters, we will see the details later. As we have published the chatbot, let us go to this Voiceflow webpage. It is about the Dialog API endpoints, and we are now on the Interact webpage. It contains the information we need when we use the Dialog API to interact with the chatbot. You can read the details. As it says, we should send a launch request to start the conversation, then, send a text request to pass the user's question or response. This is important in order to use the API correctly. If we do not follow this, it will be failed. In the response trace examples, we can see that in the payload, there is message which contains the response message from the chatbot. We will need to extract the message from the payload and display it to the user. In the requests section, it says there are different types of requests. Again, it says we should send a launch request to start the conversation, then, send a text request to pass the user's question or response. In the path parameters, the user ID is required. We will need to fill out the user ID when making the Dialog API calls. There are also other parameters, and we will talk about them later. For now, let us get the user ID. On the Voiceflow canvas, we click the Run button to start the test. On the left of the canvas, we can see a short vertical line. If we click on it, it will show the variable list. When we run to test the chatbot, it will show the variable values at the current step. Let us find out the user ID variable. We see the user ID is test user. Let us select it and make a copy. Back to the Dialog API web page, let us paste it in the user ID box. After we have the user ID, let us get the Voiceflow API key, which is needed when we make the API calls. We go back to the canvas, and we go to the main menu. We find the integration icon, and click on it. We see the API keys and click on it. Click the copy button to make a copy of the primary key. Back to the Dialog API webpage, in the authorization, we paste the API key in the header box. In the language drop-down, we select JavaScript because we are writing code in JavaScript. If we scroll down, we have already filled out the user ID. Let us go to the version ID. By default, it is development. As we have published the chatbot, let you select the project version ID as production. If not published, you may choose the development version. Now, on the code example, it has automatically added all the parameters we have entered. We can see the type of the request is launch. As we spoke previously, we should send a launch request to start the conversation. Let us click the Try It button to do a test. We see the response status is 200 OK, which means the API call has succeeded. We see an empty array because we do not have traces returned from Voiceflow. The code has all the necessary parameters for the API call, including the HTTP request options, the body, the fetch function, and the catch block. It is ready to use. We can click the button to make a copy. We can simply paste it in our code and use it for the Dialog API call. It is the launch request, so we will run this code before the text request. On the visual code, we click to add a new file. We name it as vflaunch.js. This is the launch request, and we will run this code first. Let us paste the code here. It has the Voiceflow API key. In your real product, you may add the API key in an env file for safety issue. We can see the launch request in the action type. In the headers, we have the version ID, authorization. The request type is launch. There is a fetch function, which accepts the URL and the options arguments. The fetch function returns a promise with the response object. There is a JSON method to extract the JSON data from the response. There is also a catch block to catch errors. This is a standard process for HTTP request. Next, we will add the launch code file to the HTML file. Let us copy this code and paste it above. We change the src attribute to the vflaunch, so it is pointing to the launch JavaScript file. In the chatbots.js file, we are going to add a function to communicate with the Voiceflow chatbot. We give the function a name as EmployeeBot, because it will return the employee information according to the user question. This function will accept two arguments, the question and the string time, which are same as those in the previous AI bot function. In this function, we will send the user question to the Voiceflow chatbot, and receive the answer via Dialog API. We will make API calls using the fetch function. This will be same as that in the launch file. So, let us go to the vflaunch.js file, and make a copy of the entire code. We will make some changes based on the code. On the chatbots file, we paste the code in the EmployeeBot function. The HTTP request options are same. We need to change the action type from the launch to text, because launch is used to start the conversion, and after that, we need send a text request to pass the user's question or response. So, we use the action type as text. In addition, we add the payload, and pass the user question in the payload. The user question will be sent to the chatbot during the HTTP request. All other parameters remain same. The fetch function uses the same URL, and accepts the options we have modified. The response will be converted to JSON data. We will use the extracted JSON data of the response body in our application. We can keep the code to log out the response body on the console, because it is helpful for debug. If there is any error, we can see it on the console. But we will add more code. We define a variable to save the response from the chatbot. We can extract the answer from the response body array. The first element of this array contains the message payload, so we extract the message using this data structure. The answer is saved in the VF residential variable. At this point, we can log out this variable on the console for debugging. As we have extracted the answer, we are going to display it to the user on the chat window. In the AI bot function, we have done the same thing. So, we can go to the function, and make a copy of this part of code. It is the bot HTML. We add the elements, and append it to the message form to display the answer. Let us make a copy of the code. In the employee bot function, we paste the code here. We need to make some changes. We replace the Gemini answer with the vfres. This variable has been defined previously, which saves the answer from the Voiceflow chatbot. The string time can remain unchanged. We append the bot HTML to the message form 8 to display it on the chat window. Now, we have finished the employee bot, and we can call the function. Let us comment out the AI bot, and paste the employee bot here. So far, we have finished the code, and are ready to test out the Dialog API. Let us go to the web page, and refresh the page to reload everything. We can see on the console, there is an empty array because the launch code has been implemented, just like what we got after we clicked the Try It button on the Voiceflow's Dialog API web page. Let us ask a question to query the data in the knowledge base related to the employee data. We ask, what is John's role? The bot replies, Sales Manager. This is the correct answer, which is returned according to the employee data in the knowledge base. If we ask, what is John's salary? The bot says, John's salary is $75,000. This is correct again. Let us ask, what is John's working years? The bot says, 8, this means John has 8 years working experience. All works great. We do not have any errors so far. It is magic. We want to verify that the data returned is correct. Let us go to the Voiceflow canvas. In the knowledge base, we click to see the employee data. As we can see, John's role is Sales Manager. He has 8 years working experience, and his salary is $75,000. Everything is correct. This is wonderful. Now, we have built our own chatbot, which is able to send the user question to the Voiceflow chatbot, and get the answer via the Dialog API. We have our beautiful user interface as the front end, and use the Voiceflow chatbot's knowledge base as the back end. If you have followed along, congratulations! You should now have built a chatbot using the Voiceflow Dialog API. Here, we just have shown a simple demo. In your case, you can build your own complex application via the Dialog API using the same process shown in this tutorial. Until now, we have built 2 chatbots. One is the chatbot to connect to Gemini API, and the user can ask the question to Gemini and receive the answer. The other is the employee chatbot to connect to the Voiceflow knowledge base via the Dialog API. In our code, we can implement the 2 chatbots by calling the 2 functions one at a time. For example, we call the employee chatbot, but we need to comment out the AI chatbot. This works okay, but it is not convenient. In the following, we will show you a way that the user can click buttons to choose the chatbot he wants to use. So, at the end, we will have a chatbot platform that allows user to switch between multiple chatbots with a simple click. In the HTML file, we will add 2 buttons for user to click on. Under the user info section, we will add an element with the class of ChooseBot, which will wrap up the 2 buttons. We add the first button with the ID of AI bot. In on-click attribute, we will add a callback function to the message area, where the user inputs his questions. We use the getElementById to select the message area, and add a dataset named bot. When this button is clicked, we assign the value AI bot to the dataset bot. You can use class if you want. But I prefer to use dataset, which I think is more convenient. We have the button name as AI bot, so the user knows if he clicks this button, the AI chatbot will run. The second button is same. We can make a copy of the first button, and paste it down here. We change the ID to employee bot, and the dataset to employee bot. We change the button name to employee bot, as well. Now, we have 2 buttons for user to click. When one of the buttons is clicked, the message area's dataset will be assigned with a value. If the other button is clicked, the data will be changed. In this way, we can distinguish which bot the user wants. And we will call the function to run the chatbot correspondingly. If we go to the chatbots.js file, we see that we can call 2 chatbots. As we have the dataset, we can use a condition block to separate them. We use the form, which is the message area. At the beginning of this file, we have defined the form using the getElementById attribute to select the message area. We can use the new attribute of the form, which is datasetBot, to check if its value is AI bot. If true, we can call the AI bot function to implement the chatbot. Otherwise, if the datasetBot has a value of employee bot, we call the employee bot function to implement the other chatbot. Now, the user can click the buttons to choose which chatbot he wants to use. Let us test it out. We refresh the web page. We can see two buttons on the top of the chat window. They are not well styled because we did not add styles on them. If you want, you can do that later. Let us first test to click the Employee Bot button. This will connect to the Voiceflow knowledge base via the Dialog API. Let us ask again, what is John's role? The bot replies, Sales Manager. Again, we ask, what is John's salary? The bot says, John's salary is $75,000. We ask another question, what is John's working years? The bot replies, John's working years, 8. This works very well. The answers from the chatbot are all correct as expected. Everything is good. On the console, we can see the questions and answers printed out there. There is no error. This is magic. The Dialog API is working. Now, let us click the other button to test the AI bot. Let us ask, who is the US President? The bot replies, the current US President is Joe Biden. This answer is from the Gemini API. We ask, who is the French President? The bot says, the current President of France is Emmanuel Macron. This is great. Now, let us click the button to switch to the employee bot again. We ask, what is John's role? The bot says, Sales Manager. It is good. Let us click the button to switch to the AI bot. We ask, what is the largest state in the US? The bot replies with Alaska. This is wonderful. We have tested multiple runs to switch between the two chatbots, and all run smoothly as expected. If you want to add more chatbots to the platform, you can simply do that. You can connect to your Voiceflow chatbot with the Dialog API, as demonstrated in this tutorial. You will have a very flexible and powerful chatbot platform which works completely as you desire. This wraps up today's video. Thanks for watching. If you like this video, please subscribe and give a thumbs up. If you have any comments and suggestions, please let us know. Thank you for your support.